Two things that we need to refer to when we talk about electricity, insulators and conductors. An insulator is a material in which the electrons cannot move easily. And so example is down here, you have rubber, you have glass, oil, diamond, wood. So these are, things that are pretty safe when it comes to things like electricity. So people usually say, if you know that there's like a lightning storm going around and you have nothing to go kind of protect yourself in, you should go into your car because your car has rubber tires that can pretty much ground the lightning if it does strike your car. And then you have conductors, which is a material through which electrons do move easily. So they are not the best things to have around live electricity. For example, silver, gold, copper, steel, and even seawater, which is pretty interesting. Okay, so electricity you can actually transfer charge in kind of two ways. One is charge transfer by contact, which is basically you're transferring your charge by contact, which is touching or rubbing something. So you can see here that in the first image that we have, you have this little rod that has electrons on it, negative charge, and it's touching the little metal sphere, and so you're transferring the negative charges onto there. Then there's something called induction, which is pretty much when you bring that rod, which has negative electrons on it. You're bringing it towards the metal sphere, and you're rearranging the charges that are already on that metal sphere. So you can see how there's positive and negative. As you bring this negative charge closer, it's going to attract the positive charges because, opposites attract. And it's going to dispel the negative charges. And so usually if you have a grounding wire, it will cause the negative charges to go through that grounding wire to the ground, and you are left with positive charges. Okay, so usually when you think of electricity, you think of current that's passing through something. So let's go into that. What is an electric current? An electric current is basically a net movement or total movement of electric charges in one direction. And this is measured in amperes or abbreviated with amps. Then you have something called voltage difference, which is pretty much related to the force that causes these electric charges to flow through a wire or whatever it is. And it's going to be measured by volts, which is also abbreviated with AV. And then you have something called resistance, which is the tendency of a material to resist the flow of electrons that are passing through and to pretty much convert that electrical energy into another form of energy, which is usually thermal energy. That's why you can see that, sometimes wires can get pretty hot or warm because of, especially if you have resistors, because of that kind of because of what is happening with the electrons kind of slowing down. So if you look at this image here, and resistance is also measured by ohms. If you look at this little image here, I thought it was super cute. So you have some kind of wire, and you have amperes, which is the electric current that is flowing through, but it's and you see that the volt, which is the voltage difference, trying to force this ampere or the current through this wire, but it's not being able to move because of ohms, which is the resistance that's kind of either slowing it down or, kind of holding it in place. And this helps, the resistance helps so that you don't fry electronics, you're not having an overproduction of electricity flowing through something, and it is pretty helpful. When you talk about electric current, it actually is a closed path that the electricity flows through. But there are two circuits that we talked about. We talked about a series circuit, which is just one branch. So you can see that you have the battery and you have one branch occurring, and these two light bulbs are on that one branch. So if you turn off the switch, both of these light bulbs will turn off. But if you turn it on, they're both going to turn on. Then you have something called parallel, which is when you have two or more branches for a current. So you could have a switch for each one so that, if you have one on, the other one doesn't have to be, or vice versa. We also talked about dry cell battery and wet cell battery. Dry cell battery is a battery that you have in a flashlight, in your TV remote, and then you have a wet cell battery, which is a car battery, obviously a lot more intense than a dry cell battery. All right, moving on to chapter 7, we're talking about magnetism and what they are used for. So, when we talk about a magnetic field, we're talking about a region of space that we have around a magnet. So, you can see here we have a magnet, north and south, and you can see the magnetic field around it. And this magnetic field can have an effect on other magnets that are around it. So, the south is going to attract the north and vice versa. Um, and then you also have something called an electromagnetic force, which is basically the attractive forces that a magnet has, or a repulsive force between the electric charges and the magnets that that are participating in this. Okay, just making sure I didn't skip something. All right, so now you have a transformer, which is basically a device that is going to increase or decrease the amount of voltage of an alternating current. We will talk about what the alternating current is. And then you also have something called a generator, which is going to use the electromagnetic induction to transform mechanical energy into electric energy. Remember that we talked about this when we talked about like windmills and things like that. And how important it is when you need something like a generator to convert that those two energies when you have to convert mechanical energy into electrical energy. And then a transformer is very important when we do talk about alternating current, which we will go into now. So when you have a direct current, also abbreviated with DC, you have an electric current is basically when the current is traveling in one direction through a wire. So you have some right here, you have a direct current. It's going this way, right? It's going where the arrows are pointed. It's going in one direction. But then you have alternating current, which can reverse in its direction. So it can go this way or it can go the opposite way. Hence the name alternating. It can alternate between the direction that it's moving in. Moving on to sound. Okay, so when we talk about sound, probably one of the first things you think about is sound in the music that you listen to. And if you have speakers, you can kind of visualize this. But when you have compression, you basically have the speaker vibrating outward. So if you look over here and say, this is my little speaker, you have compression when the speaker is vibrating outward, so that the particles that are near the speaker are actually being pushed together. So you can see that the particles here, where it's a little bit closer together and they're darker blue, they are, closer in relation, the sound particles, than they are in rarefaction. Rarefaction is when the speaker vibrates inward and the particles that are near the speaker are spread more apart. So compression, remember, they're just more compressed in air molecules, and then rarefaction is when they are more spread apart. Obviously, another thing that comes to mind when you talk about sound is your ear. Your ear is obviously very necessary for you to hear the different sounds that are in our environment. So, here's what our ear, different parts of our ear have to do with sound. So you have the outer ear, which is this green part of our ear, and that part is going to gather the sound from our environment, okay? So this is called our outer ear. And in this outer ear, you have your ear canal, which is usually right here. You have your auricle. Your ear canal is this little canal right here. Your eardrum is over here, and then your auricle, which is this outer part. Then you go into your middle ear, which is this purple bluish part. And this is where your sound is going to be amplified. So it's going to be a lot louder. And in this area, you have your hammer, anvil, and stirrup. Remember how I told you in class, you can remember it with HAS, H-A-S, hammer, anvil, and stirrup. And then you have the inner ear, which kind of looks like a little snail. And this is where the sound is going to be transmitted into your nerve impulse. So your sound waves are going to be transmitted into your nerve impulse, which will then go into your brain to be deciphered. Then you have, in this inner ear, you have your cochlea, you have your semicircular canals. Okay, so let's go over some words when we talk about sound. You have intensity, which is the amount of energy that is going to be passed through a specific area in an amount of time. So remember when we had the image of a computer and you had a little block on that computer screen, because that is the area that you have a specific area that energy is going to pass through in a certain time, and that's how you measure intensity. Then you have something called loudness, which is our perception of sound volume, a human's perception of sound volume. Then you have pitch, which is basically how high or low a sound seems to be. And then you have frequency, which is when you are measuring how many wavelengths pass at a particular point for each second.
Tyler just texted and said that